What is up, guys? Welcome to another episode of CCT. So today we're going to be doing the generating parentheses problem. And before we get started, I just want to say I am very open to doing any topic or really answer any questions that you want. If you message me somehow or comment on any problem in Leetcode, I will do my best to try to answer it. Yeah, just wanted to put that out there. Alright, so without further ado, let's explain the problem. So you are given a number. So like for 3, for example, you have to generate every single combination of parentheses that are valid. So for example, you have this one where they're all nested. You have this one where it's nested, or like ones around all of them, then there's 2 individually. You have this one, you got this one, and you have this one. Okay, so alright, so I guess the first thing to think of how to solve this is when you're going through every combination of something, it's usually some sort of depth first search, right? Depth first search where it's like if we have a tree, maybe it's this way, and then here it's like here, 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 here. Or, I mean, having this makes it a lot easier to solve, but even before that, I think maybe something like if you say, oh, I have a combination like this, or maybe like that, and then this, and then this, and then for 3 of them you might have this. What I'm trying to say here, why I drew these both separately, is because just because I said you should use depth first search to go through all the combinations doesn't make it obvious for combinations of what. Are you going to do combinations of full parentheses, both parentheses, trying to move both parentheses around within an already given string? Are you going to do one at a time and somehow do some logic to make sure you have equal amounts? Or is there a better way to find the combination by making some clever observation about parentheses? So what I'm trying to say is that just because it says go through all the combinations and you think depth first search doesn't mean it's so easy to solve it. But let's continue with the depth first search idea. So let's say, just back up, real easy depth first search. Let's say I have a list of numbers, 1, 2, 3, 4. Go through, make a vector of ints, or just a vector of ints for all of the numbers that you can make out of these. It's a similar idea, right? So if I said return a list of all of these, how would you do it? How do you go through every combination of stuff? Because it's a similar idea to the parentheses. There's a bit more logic with parentheses because you can't just have the braces or the bracket, no, the parentheses everywhere. But how you do this is you'd go through and you'd go through like a for loop, and you'd start each of them off. It would be recursive, and 1, 2, 3, 4. And after you've added it to one of your numbers, you would go through the function again, and then it would be 1, 2, 3, 4 again. And then eventually, when do you stop? When's the stopping point? You need an end condition, and the end condition is when you've reached 4 digits in this case, because that's the amount of things you have. So this is just showing you a simple example of how to do recursion, for just going through combinations of stuff in a depth first search style, and then showing where to stop. You stop once you get, if you're going through every combination of something, you stop once you get to the end thing. And then you put it in your vector of strings. Going through every combination and storing things in a vector of all those combinations is a very common problem. So how should we do it with parentheses? So actually, I didn't even figure this out. I was actually thinking of this way for a while, like, okay, let me start with this parenthesis, and then in the recursive function, I could put the next set of parentheses around the current string, or I could put it to the side of the current string. And I was thinking, oh, this has got to be it. But then I ran into a lot of trouble here, which is like when I already had this one, I could put it around. Let me erase this. I could put the third parentheses around it, and I could put it inside it. But then I thought, well, how would I even track putting it on the other side? And like, I just didn't see how to keep, like, it seemed like I couldn't just move. Like, there's so many combinations. It could be here, it could be around all of them. It's not like I could just move a single parenthesis through this string, just one at a time, and go through all the combinations. So like that logic was really, I was really adamant on that being correct, so I stuck with it for a while, but it just didn't turn out to be feasible, or at least I couldn't figure out the way to do it that way. So I guess maybe if you think you've gone decently through the logic of one path, maybe the way to think about it is just drop that method of going through combinations and maybe think of a different way to go through combinations. And here is actually the better way to go through combinations. You got to think, it's actually even more similar to this way than I at first thought. So let's say you're going through, let's say n equals 3. So you have 3 sets of parentheses. That means you have 6 blanks to fill in. Back here, how many blanks did we have to fill in? We had 1, 2, 3, 4, and with this one we went through 4, 1, 2, 4, and then here 4, 1, 2, 4. And here is going to be kind of similar, except we're putting a little more logic in it. So we have to have a way. So like the first character here always needs to be a front-facing parenthesis. This one could be either a front or a back, or sorry, an opening or a closing parenthesis. So if it is an open one, fine. This one could be an open or closing one, but this one can't. It has to be a closing one. So you have to think, yes, I could go through all the combinations, like, okay, this one is open, finish the rest of the loop with like you throw the rest of it to the recursive call, and then you get to here, you say, okay, let's put it this way, throw the rest of it to a recursive call, put it this way, throw the rest of it to the recursive call. But there needs to be a little more logic, like a little more, what do you call it, rules to how you could just throw characters in. Because at this point, you can't go both. You have to go with a closing parenthesis. You can't go open anymore. So if you've already thought about it, you need to always have less than, so opening always needs to be less than or equal to closing parentheses at all times. So here you could go through both of them, and let's say you go with that one, fine. Here you could go through both of them, and for this iteration, let's just say it's this one. Now for here, you need to go with closing. For here, you need to go with closing. For here, you need to go with closing. But let's say instead, like in the next iteration, you went this way. That means they're equal. So then the opening brace can be this way. It could be either. So let's just take this iteration once. Then this could be either, but this one has to be closing. It has to be closing. So as long as the open is always greater than or equal to closing, and like eventually they're going to be equal at the end, but we just don't want a case where it's like, okay, here, here, and here. No, this is never going to work as a valid parenthesis thing. We always need there to be greater than or equal to the amount of closing. And like I said, by the end, they will obviously be equal. What is the ending condition? So here, our ending condition was n equaled 4. We had the number that we had, or the string, however you want to store it in the vector, had 4 digits. What is the ending thing here? Well, it's the same. We know that the amount of characters in the string is going to be 6, or 3 times 2. So n times 2 character stopping point. Okay, so now let's code this up. Okay, so what do we need in our recursive? So like obviously this is not enough for a depth first search solution. We need to call a helper function. I'll just call this helper. I know I'm going to need a vector string output, and I know I'm going to need, so I'm going to keep track of the number of opening braces. So O count, that'll be number of opening braces, parentheses, dang it. And int C count, which will be the number of closing parentheses. And then we need the ending condition, so int n. Okay, yeah. And we can pass this one by reference so that we don't have to return it. Okay, so let's quickly make these so that we can pass it in. Vector string output. We have, yeah, that's it, right? So helper, let's put in 0 opening, 0 closing, n times 2 for the amount of characters, and then output. And then we can return output. I'll reply to that later. Nope, not now. Okay, so now in our helper, what we're gonna do is, so since we already talked about it, okay, I like to start my depth first search with the meat of the function, the real part. I'm not worried about base cases right now. I just want to get this recursive part down. So I want to say if so if you have less opening than closing, you can put, sorry, if you have less closing than opening, you could put either of them. So if closing count is less than opening count, you can put either of them in here. So let's say, I guess we have to make it temp, string temp. Oh, we should have a temp here. We need like a current string. Yeah, so we have a current string. So current is going to plus equal, let's put that closing brace there. Okay. And then let's do helper and o count, and then closing count, but then +1 because we just used it, and then n, and then current, and then output. So if the closing is less than the opening, we can put we need to call this function with both the opening and closing. So then we could do current dot pop. I think that's allowed in strings. Wait, string pop. Ugh, I've been looking up a lot of JavaScript. That's why it thinks. Is that a thing? I thought it was. Yep. It's pop back. Okay. And then I could do current dot current plus equals the opening parenthesis, and then call it like so. I really am not a fan of this O count and closing count. Let me just name it opening parenthesis, closing parenthesis. Oh, closing parenthesis is less than opening parenthesis. This means that we can put in either. Oh, wait, no, we can't. We can't just throw in another opening parenthesis. I take that back. Why can't we just randomly throw in another opening parenthesis? Well, because what if we've been adding too many opening parentheses? The opening parentheses has its own if statement. So if the opening parentheses is less than n divided by 2, actually, let's just make it like that. If it's less than the number of parentheses, then we are allowed to add it in as an option. So note that if the closing parenthesis is less than opening parenthesis and opening parenthesis is less than the total number, then it will put on the closing parenthesis, throw it through the recursive loop, and the opening parenthesis, and throw it through this recursive loop. I guess we don't need the pop back, but do we? No, we don't. Got to get rid of those unnecessary functions. And so then our base case becomes, so when we stop it, is if current length, or actually, okay, so we could do if the length is equal to n times 2, but we could also do if OP equals, if the opening parenthesis count equals the total number of parentheses, Then what we could do is output dot push back the current and then just return. There's no point in continuing from there. Okay, let's review. Actually, it makes more sense for this part to go up here. Okay, so if you have, so n is the amount of parentheses you're allowed in total. So if you have less opening braces, parentheses, god damn it, why can't I say parentheses? If you have less opening parentheses than parentheses that you're allowed, then let's throw one on. So if this is a tree, let's go over here for a second. If this is a tree, we're going to be going down here for a while until we get to the point where, or I guess it's more like this, where we have all the opening parentheses we're allowed to use. Okay, now I need this back. Whatever. Okay, so once we have all the ones we are allowed to use, then we get to the, so we have all of those, and then it's like, wait, a tree is not a good way to represent this, is it? Because then you need to do all of the closing parentheses. So, opening. Wait a damn second. Doesn't need to be after this part. Opening. Once it gets to 3, it adds it in. Oh shit, no. It will get to 3 though by the time it gets here. Wait, what if I do put it back here? Then what's our tree look like? Then we got opening, then we got opening, and then here we have opening, closing, because it's going to go through here, then here, then here. It's going to open up another, it's going to do this with an opening, and yeah. Okay, let me see if this is actually right first. Sorry. What? Oh. String x, whatever. I didn't think this was right. So opening, closing. See, explaining it makes you actually think, because I only briefly looked at the answer. So you're opening, closing, opening, closing. Let's change this back to 2. So that's the only time you're allowed to return. I'm returning too early. That's better. Okay. I was returning. I can't return when the opening parentheses equals the closing, or when it equals the amount of parentheses, because then I'd leave out the last closing parenthesis. Let me try to draw out this diagram though, because I think this has to be the answer, because wow, that's not working out. Let's move over to here. So let's see, we go opening, opening, opening. We go opening, opening. This is just the string that I'm following. And then here, it's going to go through here, 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 and then it's not going to be less than n. So then it's going to start doing the closing parentheses. And then it comes here, then it's going to do closing parenthesis, closing parenthesis, closing parenthesis. Push that back. Pop back, pop back. Actually, I can't draw it out like this because there's too many restrictions. Like, yeah, no, I can't. It's because here, instead of having that, I could have. It's gonna eventually come to here. Here, yeah, you know what it is? It's gonna go like this. The weird thing is this is not ever gonna happen. But then here it'll split up into, like, once it recursively, it'll realize that this has no future, this has no future, and then it'll eventually bubble back to this area where it's this, and this, and then this, like that. And yeah, so it is a tree. It just is a weird tree because a lot of the paths are going to be stopped. Which actually kind of brings me to another point, that what is backtracking or pruning? It's basically depth first search when you're crossing out things. That's just like pruning. I'm just pruning these because there's no way we could have another opening parenthesis if we're only in that 3 parenthesis pairs in total. Last thing, I think we forgot to check if n is 0, does this work? So if n is 0, then the current length will equal n times 2 because that's 0, so then it will just return. Yeah, it seems like it should work. Let's put it in. Yeah, okay, I feel confident. Hopefully it works. Yay! Ooh, I'm really fast too. Okay, so hopefully you guys learned something, and remember that when you're looking for combinations, using depth first search is almost gotta be the answer, but you're gonna sometimes need to be clever with pruning and like backtracking, like, oh, I can only have this many open parentheses and this many closing parentheses at this point, and then all of them, if you want to find all the combinations and make a vector of all those combinations, you're gonna need an ending condition to put it in this output vector. And for ours, it was just, it had to be 6 characters, or the length of n times 2. Okay, I'll see you guys later. Hope you enjoyed the video. Peace.